दवाई नहीं खाया यार, मैं भूल गई। दवाई खा लेती हूँ यार। क्या गिर गया? हम प्यार है तुम्हारे, दिलदार है तुम्हारे, हमसे मिला करो, हमसे मिला करो, कोई सितवा अगर हो। What the hell? ये हटा देती हूँ मैं, अभी मैं नहीं कर रहा था। राजू भाई क्या हुआ राजू भाई को? मैं बहुत नाराज हूँ राजू भाई आपसे, सच में नाराज हूँ अब तो। हम प्यार है तुम्हारे, दिलदार है तुम्हारे, तुमसे मिला करो, मिला So here we can see what is parallelization in LinkedIn. So here we can see what is parallelization. So here we are going to workflow of LangChain with parallel, sorry, workflow of LangGraph. So with parallelization. So what is parallelization in LangGraph? Okay, so here we can see what is parallelization in LangChain. Okay, so in LangChain, nodes usually execute one after another in sequence defined by edges. Okay, but when tasks do not depend on each other output, they can run in parallel. Okay, this one. Okay, like you have multiple like if you have input like this here, and if you want to run task parallelly and they don't depend each other, so you can execute parallelly like this, task 1, task 2 and task 3. After that, here we can combine it by aggregator, and it will generate the answer. Okay, so here you can see uh, in line graph, node usually execute one after another in sequence, but task, if task do not depend on each other, then we can use parallelization in line graph, and they can run with the help of parallelization in the form of parallel. Okay, so here you can see how it works. Parallelization achieved by creating multiple nodes that operate independently. These are the multiple nodes, they are working independently here, and connecting them to a common point. Okay, here you can see like start and optionally merging their output into single downstream node. Okay, so connecting them into a common starting point like start this one. Okay, and these are the independent nodes, and now we are going to combine these node here, merging their output into a single downstream node. Okay, so line graph handle the automatically when node are independent and can use multiple threading or async execution under the hood like async or thread pools. So here benefit of the speed, they can run independently. Okay, save it's they are they save your time. Okay, and scalability, handle large workflow efficiently, and modularity, keep the graph structure clean and reusable. Okay, so here um, what happening here in parallelization. So len graph allow to create a workflow of task called a node. Okay, so here some tasks can run at the same time. Some tasks can run at the same time if they don't depend on each other. This is called a parallelization. In this example, we are making a short story, character setting and story premise. Okay, so all three are generated in parallel, then combined into a single story. Okay, so here these things and all three we are going to execute in parallel form, and after that they will combine in a final story. So here you can see workflow of this start. So we can start by using start, it is a beginning of workflow, and generate the character. Okay, so AI generate the character name and trials, generate the setting traits, sorry, generate the setting, AI describe where the story happened, and generate the premise, AI write a one line plot idea, combine the result, AI merge the character setting and premise into a story intro, and end workflow finished. Okay, so here you can see I'm going to load I'm going to load load your API from .env. So here I'm going to load API, and now and after this I'm going to connect grok LLM. Okay, so here I'm going to write code import os. Okay, here I'm going to write from, okay, import os, and here you can see from .env import load.env, and here after this I'm going to create load dot env. Okay, where is my code? Oh, this one, import os, from .env import load.env and load.env. Insert a cell above A. Okay, name load is not defined. So here this is the load underscore .env. Okay, and here you can see from langchain underscore grok import chat grok, and here I can write this line here, import os dot environment environ. Here I am going to pass API keys variable grok. Here you can see grok underscore API underscore key. Okay, from here I already have env file, this one. Okay, now I'm going to close this bracket, and here you can see os dot get os dot get env. Here I am going to write again this name, grok API key. Okay, close quotes, and after this I'm going to so okay, here I have load .env file that we can access our API key from env file. Okay, so chat grok connect to grok LLM like OpenAI, but faster, it is faster. Okay, so here I'm going to import chat grok. Okay, and after this I need to write here you can see llm equals to chat grok. And inside this I need to pass model name. So model equals to in course llama hyphen 3.1 8 billion 8b hyphen instant. Okay, so I'm going to use model this one, and here now I need to create a variable which called a result equals to llm dot invoke, that we can invoke query from llm from this. Okay, so here I'm going to write inside this query like hello. Now I'm going to print result. Okay, I need to copy this, and here okay, so move this cell down. Okay, now I am going to insert cell below. So here I need to copy this, okay, because it is not in Python. I need to delete this. Okay, so I got error, then chat grok is not defined. I already defined this one, chat grok. Okay, so I did mistake here. Okay, it's grok. Okay, so here you can see connect to grok llm. Okay, so here I am going to create llm equals to chat grok model, and this is the model I am going to use in our code that we get answer from this model. Okay, so result equals to llm dot invoke, that we can get answer from this for this query. Okay, and this is the result, and you can see AI message give you how can I assist you today. Okay, AI message equals AI message, here you can see content equals to hello, how can I assist you. Okay, and these are the metadata and everything. Okay, model name, prompt time, queue time, okay, total time, finish time, so everything is here. Now here you can see you load your grok API, these things, and use llama 3.1 8 billion parameter model for text generation. Okay, and after this I'm going to create a state. Okay, so state, what is the state? State is like a share memory between the nodes. Each node will read or write to this state, and state dot class state type it. Okay, each node will write here state dot class, each node will write to this state. So here okay, each node will read or write to this state. Okay, so it like a share memory between nodes. So here I'm going to create state class equals to state and type it for typecasting. So here topic should be in string, character should be in string, setting should be in string, and premises should be in string, and story intro should be in string. Okay, so this is the state. Now I am going to build uh, what, so here I need to run it again. Type dict is not defined, I think I missed it. I need to import type dict also. So here from from typing import tactics, from typing import tactics. Okay, here after this I already have code inside this file, so I am explaining you again. Okay, this thing, and here I'm going to create a graph. No, I'm going to create nodes. Okay, so I already have code for nodes. So here I need to copy it and paste it here. Okay, actually I did mistake here. I need to import these things from typing extension. This is the typing extension, not a typing. So here I need to write this and rerun it again. Okay, I need to remove this because I already defined it. Now I am going to create nodes. Okay, so here you can see I already create state. Okay, and where each node will read and write to this state. Okay, so here after this from len graph import state graph start and end. Okay, from ipython dot display import image and display. Okay, so these are the nodes. Generating character, I'm going to create node for generating character. Here I'm going to pass state that the node and write the state. Okay, and generating character, I have this I have explained here in doc string generating character description. Okay, so message equals to llm dot invoke, and here in f string create two character name and brief traits for a story about the topic. Okay, so return character message dot content. Okay, and after this I'm going to create another node getting setting, sorry, generating setting. So here you can see I have already defined start, generating character, generating setting, and these are the nodes, and after this and okay, and here generating setting means AI describe where the story happen, and generating character AI create a character name and traits. Okay, and generative generate premise means AI write one line plot idea, and combines means all merges character setting and premise into a story intro. So here we can see generate setting. Okay, so here you can see message equals to llm dot invoke describe a vivid setting for a story about the topic, and here return setting message dot content, and generate premise means generating a premise. Here you can see a message equals to llm invoke write one sentence plot premise for a story about the topic, and return premise equals to message dot content premise column, sorry, message dot content, and here I'm going to combine these nodes. Okay, so these nodes run parallelly, like this one for generating premise, or this one for setting. Here you can see a start, generate character, this is the start, generate character, and here second generate setting, this is the generate setting, this is for generate setting, and this is for generate premise. Okay, so we have three nodes, and now we are going to combine these things. Okay, so here I'm going to pass a state that it will read and write the state. So combine character setting and premise into a intro. So here message equals to llm dot invoke, here write the story introduction using these elements. So this is for character, this is for setting, and this is for premise. Okay, so here we combine these things and return story intro message dot content. Okay, now I'm going to run this. So here we are going to move. So here we are going to move workflow of Durandes. Uh, Sorry, guys, I have got call. Okay, so here I can see, like you can see, these are the nodes: generating character, generating setting, and generate premise, and generate, sorry, and these are the three nodes I have created, and all these nodes here, with the help of this function, define combine, sorry, def combine elements. So here I have combined these nodes, okay, and written story intro message dot content. Okay, so all parallel nodes feed. Okay, so okay, note this. Now I am going to create, what I am going to create. Here you can see insert. Okay, so here I am going to create like a graph. Uh, Build graph. Okay, and here graph equals to state graph. Okay, and here inside this I am going to pass state, that node can read and write state. Okay, here now graph dot add node. Okay, I am going to add nodes. So add node. Here these are the nodes, and bracket for character. Okay, so here this is the character. Mm, Character, comma, generate character. Okay, and here after this, for generate setting, this is for settings. Generate character, generate setting, and here after this I need to create another node. This one, generate setting. Need to copy it and paste it here. Okay, this is generate characters. I'm going to create another node for this one. And here I can replace it with premise. Okay, now again I need to create another node, that is combine. This is for combine. Okay, combine element. So here I need to paste it here, and I need to create combine, combine, combine elements. Okay, so create a graph object. Okay, and add node for each function, like a small building block. Okay, so here these are the node in our graph. Okay, I need to run this. After this I need to create edges. Okay, so here in comment I need to write define edges parallel execution for start. Define edges for parallel comma execution. Define parallel execution from start. Okay, so here I need to define edges. Okay, so graph equals to ah, oh what, I need to copy this, and here graph add edges. Okay, here inside this I need to start, keep start here, let the key start all the edges parallel start, and here I need to pass character. It should be in brackets. Okay, and after this I need to create another edge for setting. Control V, Control V, Control V. Okay, this is for setting, this is for premise. Okay, so here three nodes start together from start. Okay, and they run parallelly. These are the three nodes. Okay, they are going to start parallelly, these three: character, setting and premise. Okay, and after this I need to create another line: graph dot edge add edges character. Character, here I am going to pass this. Now I am going to combine these three. Okay, okay, so I need to copy this. Okay, character, setting and premise. Okay, so you can see here in first three node, this you can see three nodes start together from start, from this start, and they run parallelly. And here all nodes, all parallel nodes feed their output into combine. Okay, so they are going to feed their output into combine nodes and combine and create a final story and goes to end. Okay, so here premise, this is for character, setting and premise. I need to create another one for end. Okay, because I need to end these things by using combine. So here I need to pass combine here, and here I need to write end, that it will end. Okay, so here these are the three edges when three nodes start working parallelly and create a building block, and these are the for combining character and setting, setting also combine here, and premise also combine, and these things here. Okay, now all parallel nodes feed their output into a combine. Okay, and combine create the final story and goes to the end. After this, here. Okay, now I am going to compile and run. So here I need to put heading compile and run. So here compiled compli compiled graph equals to graph dot compile. So here graph dot image equals to compile underscore graph dot get graph. Okay, so here I am going to compile graph. This is the variable, and here we are going to graph dot compile here and generate the image. Graph image equals to compile graph and get graph dot draw marmad image, marmad png, marmad underscore png. Okay, that we got graph image in the marmad png form. Okay, now I am going to display this graph. So here display equals to display and display image so graph underscore image. Okay, I think I got error. Display image, syntax error, incomplete input. So here I got error because of uh, spelling mistake of display. I wrote DISPLY. Okay. So and I did another mistake. So here I need to like I don't I can't write thing like this. Like start should be no should be start, not written string. Okay. So here you can see this one here, and also like this is we can't put it in string. So here I need to run this, and again here I'm going to compile the graph. Okay, so this is our graph. So you can see here start, and these are the parallel nodes, character and premise and setting, and these are the combining, and this will end here. Okay, now I am going to ask the question, like state equals to topic is time travel. Okay, so result uh, compile graph dot invoke. Here I am going to pass state and print result story intro. So what is the story intro? Here this one. After combining we got a story intro. So now we can run, and this give you the story, the heart of crowns and where the fabric of time with the intricate. Okay, so this is the story generated by model. Okay, so I think you got it. What is parallelization? Parallelization, like if you have to, like if you have different tasks, and they don't depend each other, then you can use parallelization. Okay, so they will create multiple nodes independently and connect them to a common starting point like start, and after this we can combine this and merging this and got output in last stage. Okay, so here you can see here this is code for load your API keys, and this is for models that I'm going to use llama, and this is for state. Okay, and this code for creating node, we have different nodes. Okay, and here you can see build the graph and create edges parallelly, and I need to start it parallelly. And here you can see we are going to combine these edges. Okay, adding an edges, compile the edges. Okay, and here we are going to compile our graph. Okay, and got mermaid image in PNG form, and here I got the stories. Okay guys, if you like, I hope you like my video. Please if you have any doubt, do comment. Bye bye.
Sorry, guys.
20 13 कितना हुआ? 20 13 3 3 6 2 3 36.
So here we are going to move. Sorry, guys.
19 30 13 30 3 30 9 10 11 12 13 14 15 1 2 3. Hello. Today I'm going to move on prompt chaining. Okay, this is a work. This is the workflow of LangGraph. Okay, so we are all learning workflow of LangGraph. Okay, so with the help of prompt chaining, how can we work in line graph. Okay, so here you can see prompt chaining with line graph allow you to divide a complex task into a smaller connected stage. Okay, so like if you have prompt chaining, with prompt chaining, LangGraph allow to divide a complex task into a smaller or connected steps. Okay, so each steps or nodes represent a specific action, while the connections edges define how the information flow between these steps. Okay, so here you can see we have this is the visual flow of prompt chaining. Like if you have input, then it will pass to the it will call LLM. Okay, so here after we new okay, so here we can see define the task. Okay, so start by breaking down the main problem into smaller manageable subtasks. Okay, if you want to generate detailed report, you could divide into these two. Like if you want to generate reports. Okay, so now we need to divide it into a small task. Like first step is gathering data. Okay, second step is analyze the data, and third step is the writing summary. So each of these steps will become a separate part of your LangGraph workflow. Okay, so here you can see how prompt chaining work with LangGraph. Okay, so each subtask become a node in LangGraph structure. Okay, each subtask become a node in your LangGraph structure. Okay, so this will become nodes in our LangGraph structure. A node contain prompt or function that perform a specific action. Okay, so for example, list key fact about topic X and summarize the following text. Okay, so this modular approach make your workflow clear and reusable. Okay, so after this, first of all we need to define task and create a nodes and establish edges define how the node are connected. Okay, in what sequence they are execute. For instance, the output of gathered data node become the input for the analyzed data node. This ensures that connect flow properly through the entire chain. Okay. After this, after establish edges, here we move on execute the graph. Here once your node and edges are defined line graph, so you can see here process node in sequence and passes information along to edges and generate redefine result step by step. The structure help the model think more logic and coherently. So iterate if needed. LangGraph support conditional logic and loops allow your workflow to revisit previous node and generate a result if it is fail, and advise behavior based on the adjust the behavior based on the information outcome. So here you can see this is the flow. Okay, here like if you have a different task. Okay, then uh, it will pass here in the gate. If it is fail, then it will going to regenerate it. Otherwise it generate the output here in sequence, or if they have different nodes. Okay, I think you got it. Here you can see like we need to start. Okay, and think generate the generate and check. Okay, so here this is the first step, start and generate. We are saying like that generate, write a one sentence story premise. Okay, we are going to say this to LLM, write the one sentence story. So start, generate and check if it contain like a bad punctuation, like a question mark, or this one in the story, it will fail to generate. Okay, otherwise it will pass and improve and add vivid details. And after this we need to polish and it will end. Okay, so here you can see like this, generate. Okay, check here if it is has a like bad punctuation, then it will fail. Otherwise it will polish, improve and give you output here and at the end. Okay, so here you can see generate, create the initial one sentence story, check validation store if it is contain question mark or what is this here, I forget it. Okay, it fails and fail, loop back to generate to retry. Okay, it will back. Otherwise if it is fail, then it will back to generate. Okay, then retry it. And pass, move to improve. Here if it is pass, then it will move to the improved. And after this we can polish, add the creative twist. Why add the creative twist? And after that it will end, final story complete. Okay, so here I'm going to this. Okay, here I'm going to load these things that we can access our API keys from .env file. And this is for accessing grok model. Okay, and here you can see this is the model. I'm going to use model equals to llama 3.1 8 billion parameter instant. Okay, and here I'm going to invoke the result from LLM. And here I need to run this. Okay, I need to select my virtual environment, this one. Okay, I have already selected it. Okay, so here okay, this is the message by AI message. By AI message equals to content equals to hi, how can I help, hello, how can I help you today. This is the additional. So these are the all metadata and everything. We are going to use this model. Okay, total number of tokens, this one, this is the total number of the tokens. Okay, prompt timing, queue time. Okay, so these total time, model, stop. Okay, so we have everything here. Now I am going to write now I am going to create states. I need to copy it and paste it here. Okay, okay, from typing extension import type dict. And here I am going to define graph state. State are used to share memories between the nodes. It will help to the read and write the nodes. Okay, and read and write the information between the nodes. Here these are the we already have topic, story, improved and final story. Okay, these are the variables I define in a string. Okay, and type dict used for typecasting. Now I am going to define and build nodes. So here I need to copy this. Okay, I need to remove this state because I already created. I also remove this one. Okay, so here I need to keep it in top. Okay, so here I am going to import lang graph dot graph state graph start and end. Okay, this is for start, this is for end, and this is for initialize the graph. And this is for from ipython dot display import image and display, that we can display our graph. Okay, and here okay, after this I need to define nodes. So these are the nodes. Syntax error, where is the syntax error? State topics, line number 5. Mhm. I got error here. F string write a syntax story my state. What is the F string unmatched. This graph, this one. Well, the story. Okay, once. Okay, here I have got error f string unmatched. Okay, so this is string unmatched, so I need to put it in single quotes because it has double quotes. Okay, then I need to run this. Okay, so this is our first node. So here you can see I got error because of unmatched string. Okay, f string unmatched. Okay, so they have a single string, like single quotes in string. String has single quotes. Okay, so I also keep it and single quotes that it will match from the other nodes. Okay, so this is our first node. Okay, generate the story. So message equals to llm dot invoke. I'm going to ask write a one story, one sentence story premise about topic. Okay, so here you can see return story message dot content. Okay, stage are used for memory. Okay, so here you can check this is for generate the story, this node for generate the story, and this node are used for check the conflict, like it has a exclamation. Okay, so this is exclamation and question mark. If question mark in state story and or exclamation in the story, so it will fail. Otherwise, if it does not have any bad punctuation, then it will pass. That's why we return pass here. And this is for if 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 we successfully passed. Okay, then we need to go in next step, which is called the improve. So here this is the node for improve. Okay, here I'm going to pass state, and here message equals to llm dot invoke, and here enhance this story premise with vivid details. Okay, and here return the improve story message dot content, and this is for polish. Here I am going to create polish node. So add unexpected twist to the story. Okay, improve the story. Okay, so these are the nodes for generate, check, fail, pass, improve, polish, and end. Okay, generate, check, improve, polish. Okay, this is this will handle pass and fail logic, check conflict. Okay, now I need to run this. Okay, now after this I need to create a graph. Okay, so here build graph. Okay, so here graph equals to state graph. Okay, so here we are going to add a nodes generate, improve, or polish. This one generate, improve, and polish. Okay, so this is the nodes we are going to add inside graph. Okay, generate, improve, and polish. And here you can see generate story for this function, and improve, and function is improve story, this one. So we are going to call this node here improve story and polish story. Okay, so here these are the nodes that we can build our graph. Okay, after defining nodes, now I need to define edges. Here control C, control V. For edges I have this one. Okay, so you can see graph dot edges start. This will start and what is start and this one. here this is the first step, start, that we can start and generate. Okay, here you can see start and generate, and we are going to define condition here, so that's why we are going to apply graph dot condition edges here. Okay, so here you can see after generate it will check that it will pass. If it is pass, then we need to improve it and polish it. Okay, otherwise it will fail, then we can regenerate it. Okay, so here fail in column generate, and pass, then we can improve it if it is pass. Okay, so this is for another. Here you can see this generate and generate the conflicts. So here this is for start and this is generate, and here we are going to check conflicts like it has bad punctuation or not. Okay, we are going to check. If it is fail, then we can going to again generate it and pass if it is improve. Like if it is pass, then we improve and polish and end. Okay, so here where here, and after this we need to add edges, improve and polish, and graph dot add edges, polish and end. Okay. Hmm. Now I am going to compile our graph. Okay, so here I need to copy it, this one, for compile the graph. Then paste it here. No, I'm not going to touch this. Okay, so here you can see I'm going to compile our graph. Okay, so compile graph equals to graph dot compile, and here for visualization graph image equals to compile graph dot get graph image in marmot png. Okay, and display image graph image. Okay, that we got image here. Okay, here you can see start generate. Okay, start generate, these are the node. Here start and generate. If it is pass, improve, polish and end. If it is pass, here improve and polish and end. Improve, polish and end. Otherwise if it is fail, then it will go back to the generate. Okay, now I'm going to run the graph. State equals to topic agentic AI system, and result equals to compiled graph dot invoke state. So here I need to uncomment this, so I got result here. Okay, so topic is agentic AI system, and story in this in the in the near future the emergence of a highly advanced agentic AI system named Previous, capable of autonomous decision making and self awareness. Okay, so these are the content which I got. This is the topic and this is the story. Okay, now I'm going to print improve story and polish story. So here this will improve and polish story. So here this is the improve story, this one. In the year of 2055, world witnessed the emergence of reverse. Okay, so this is for improve story, and here I also have polish. Where is the polish? Improve story and polish story. Okay, we haven't print polish story. We have final story. In result, you can see here. Polish story, polished. So you can get here. Okay, I need to remove this. I need to print it one by one. Okay, improve story, and here I need to okay. So here this is for improve story, and this is for policy story. Okay, so here you can see this is for polish and this is for improve. Word verdict through purpose. Okay, now so guys, topic has been finished. So you can see here I'm going to revise everything again. So prompt chaining. Okay, so this is the workflow of prompt chaining. Like if you have a prompt, like if you have task and you want to divide it into a different smaller task. So I mean prompt chaining with line graph allow you to divide a complex task into a small task and connected state. Okay, each node represents the specific action, and while the connection define how the information flow between the those steps. Okay, so here we can divide our story in different tasks like gathering data, analyze data, and write the summary. Okay, so here working of this, first of all we need to create nodes, establish edges. Okay, execute the graph, and iterate if needed. Okay, like we can apply at the conditional logic or conditional edges. Okay, so here this is the flow I already explain it. Now you can see here we need to start and generate the story. Okay, and here you can see it will check if it is fail, then it will go back to the generate again. Okay, otherwise if it is pass, then it will polish of this story, and sorry, it will improve and polish the story and goes to end. Okay, after this here you can see we are going to load API key and model, and here this is the define that we can create our graph. Okay, these are these code for nodes that we can create different nodes. Okay, store, generate story, check confidence, improve story, and polish the story. Okay, and here we can build graph and add the nodes here, and this is for define the edges. Okay, and here this is for compile the graph. Okay, and we got graph in murmured image. Okay, and this is the topic, run the graph. Okay, so we are going to give provide here topic equals to agentic AI system and compile dot graph, compile graph dot invoke state, and this will give you this things. Okay, now here you can see I'm going to print improve story, and this is for improve story, and this is for polish story. I hope you like my video. Bye bye, take care.
So hello. Today I'm going to move on prompt check. So here you can see, so we are going to give provide here topic equals to agentic AI system and dot graph, compile graph dot invoke state, and this will give you this things. Okay. Now here you can see I'm going to print improve story, and this is for improve story, and this is for polish story. I hope you like my video. Bye bye. Take care.
जाना तू मेरे साथ दूंगी तुझको प्यार में। हेलो संजय। So here you can see, now I am going to move what is routing in line graph. Okay, now I am going to move, the topic name is routing in line graph. Okay, so routing in line graph means the workflow can decide what to do next based on the condition or output. Okay, so it in simple word I can say it will decide a route automatically according to the condition, based on the condition. Okay, just like taking a different path. Okay, so here you can see, normally a graph run from one node to the next node in order.
So here you can see now I
Okay guys, so now I moved on topic of next topic of workflow of line graph. So that is routing. What is routing in line graph? That in simple word I can say routing, that it will, or what is the routing? Routing means it will automatically taking route, okay, and decide what to do next. Okay, so routing in line graph means workflow can decide what to do next based on the condition or outputs, just like taking different path in flow chart. Here you can see, like if we have a router like this. Okay, so first of all we need to start it, and we have different nodes like this: story and joke and poem. Okay, like if you say like generate the joke, then it will take the router path this one for joke. Like if you say for another example, like if you ask the about the poem, then it will poem. Like and if you want to listen story and want to generate a story, then it will take the this route and end. Okay, if you ask the joke, then it will take a joke end. If you ask the for poem, then it will take this route for poem and it will end. And if you want to ask related query to the story, then it will take this route and okay, so it will automatically decide what to do next based on the condition. Okay, so normally a graph run from one node to the next node in order. Okay, so okay, but the routing, the graph can choose which node to go next. Okay, so it will automatically choose by graph that node to go to the next, which node go to the next. Okay, so depending on the what the model decide, depending on what the model decide. Okay, so why routing is useful? Allow to build a smart and flexible workflow. If you just tell me, if you just say tell me a joke, go to the joke node. If you just say write a poem, go to the poem node. If you just say write a story, go to the story node. Okay, so here how routing work: decide the next step, story, joke, poem. Okay, any of one, and apply the condition, check decision and route to the correct node, and execution, run only the selected node, and end the workflow, stop after the node finished. Okay, so here I'm going to write here. Okay, sorry, I need to select kernel. Actually I am moving on, I moved on Jupyter notebook because my Visual Studio didn't work as of now. So I am doing coding on currently I am doing coding on Jupyter notebook. Okay, mm, here I need to select this. So this is for import, like we are going to import .env, that we can access the API, Grok API. And this is the model, so I need to change model name. Okay, so I don't want to use this model. So here I already have this code, so I took model name from here. I need to copy this and paste it here, here. Okay, okay. And if you want to use chat OpenAI API, so then you need to access model from GPT, like GPT-4, GPT mini. Okay, so here this is for accessing the model. So result, I'm asking the result equals to llm.invoke hello and result. Okay, this is the AI message generated by AI. Okay, okay, you can see here how can I help you today. These are the additional argument, response metadata, tokens. Okay, queue time, prompt time. Okay, so this has everything here. Now I am going to write, actually I already have code. Now I need to import something, and I need to write code for routers. So here Here you can see from typing extension import literal. Okay, literal are used for typecasting. Okay, and pydantic also used for typecasting. So here from pydantic import base model and fields, and from LangChain core message import human messages system message, and from typing extension import typedict. Okay, it will also provide a dictionary in key value format with a type like integer or anything. So I'm going to create a schema for structure output used as a router logic. Okay, so route equals to, so here class equals to router inside this base model, and here state literal. Okay, so here this is the poem, story and joke. Okay, so we have three things: poem, joke and a story. Okay, so we have three route, and field equals to and field description equals to the next step in the routing process. Okay, so router equals to llm dot with structure output route. So augment the llm with the schema for structure output. Okay, okay, so this is for literal means like if you have a poem, story and joke at the runtime, if you want to change it, then it will not change. Okay, this will throw a error, so that's why we are going to use literal. Now I'm going to run this, and after this I need to create states. Okay, so here this is class for the state. Okay, state are used to store data as it flow through the graph. Okay, so if we use if we throw the data in the graph, like this is for user input. Okay, this is for decision. Okay, and this is output for like it will generate a actual text by llm. Okay, and after this I need to create nodes. We have different nodes. Now I'm going to copy it. Okay, here you can see these are the nodes 1 llm call first. Okay, this is for generate the story. Okay, that it will generate the story because we have three nodes: poem, story and joke. Okay, so I'm going to generate a story. Okay, so here this is the function llm call 1. Okay, and here this is the description. Okay, write a story, and result equals to llm dot invoke import. Okay, and return output. Okay, so this is for story and this is for joke. This node is used for joke. Like if you want to if you want to ask AI for joke, then it will call this route. Okay, this node. Okay, and here you can see this is the description, and print llm call to is called. Okay, and this is the result llm dot invoke state import and output result dot content. Okay, and this is for node 3. Node 3 means poem. Okay, so this is, if you ask the poem, then uh, model uh, model will get this node. Okay, so result equals to llm dot invoke state this is for input and this is for output. Here we got output. Okay, in result, and here you can see we are going to route the input to the appropriate node. So llm define the routers for these nodes, node 1, node 2 and node 3. Okay, so here decision equals to router dot invoke. Here I am going to pass system message equals to content. System message, inside the system message I pass content equals to route the input to the story, joke or poem based on the user request. Okay, that user will get answer from these things. Okay, and this is the human content state input. Like if human give the query like from create a joke and create a poem and create a story, then it will route correct path automatically. and then give you a decision. Okay, here decision equals to decision dot steps. Okay, now I need to run this, and after this I need to create graph. Okay, I need to create what? Conditional ages. Okay, so here I need to pass it and copy it here. These are the conditional ages. Okay, so define route decision, this one, route decision. Okay, and state equals to state, here I am going to pass state. Okay, so return, this is the our new function for based on the conditional ages function to route the appropriate route to the appropriate node. Okay, so like return the node name you want to visit next. Okay, so if state decision equals to story, like if you want to ask a story, then it will return answer from LLM call 1. Okay, from this one. Okay, else if you ask the joke, then it will generate the answer and return the answer from LLM call 2. Okay, if uh, like if your question related to the poem, then it will return LLM call 3 from this one. Okay, now here this is the decision. Okay, return decision. So decision dot steps, here this one, decision equals to router dot invoke. So I take this variable here, decision. Okay, and this is the node function name. Okay, and this is for story, joke and poem, these things, story, joke, poems. Okay, and after this I need to display our graph. So here you can see so I'm going to copy and paste it here. Okay, okay, so here I'm going to import len graph. Okay, import state graph start and end, and from ipython.display import image and display. Okay, so here router builder equals to state graph, that we can initialize our graph, and here I'm going to add nodes, router node dot add node. So this is for LLM call 1, LLM call 2, LLM call 3. Okay, these are the node LLM 1, LLM call 2, LLM call 1, LLM call 2, LLM call 3, and LLM call router. Okay, these are the nodes. Okay, I'm going to run this, and after that add edges to connected node. Okay, so here I'm going to add these things. Router underscore builder dot edges start. Okay, so here start from LLM call router. Okay, so we are going to start LLM call router. This one, LLM call router. Okay, and here this is the conditional edges, like LLM. Inside this I need to pass LLM call router and route decision. Okay, so it will take automatically it will automatically decide in which path I need to go, or I need to execute it. Okay, so here route decision, inside the route decision you can see here LLM call 1 equals to, these are the name written by the route decision. Okay, this is the name written by the route decisions, and name of the next node to visit. Okay, LLM call 1, LLM call 2, LLM call 2, LLM call 3, LLM call 3. Okay, and here close the bracket and key separate by comma, and here you can see here this is for edges. Okay, router dot edges llm call 1. I am going to end these things. Okay, end with llm call 1, llm call 2, and llm call 3. These are the um, nodes that will be going to be end. Okay, and this is for start with llm router, llm call router, llm underscore call underscore router. Okay, I think you got it. Now I need to compile workflow. So router workflow equals to route builder dot compile, and here we are going to show image of the graph in Marmot PNG that we can see flow of it. Okay, so here you can here this is for start LLM call, that it will automatically decide which node should be called, LLM call 1, LLM call 2, LLM call 3. Okay, if it call LLM call 3, then call it and it will be end. Okay, like if you ask the question from LLM call 3, what we have in LLM call 3? Okay, poem. If you ask related to the poem anything, then it will call and end. Okay, so here after this I'm going to ask state equals to workflow dot invoke input, or write me a joke about agentic AI system, and output, this will generate output from LLM call 2. Okay, this is the answer because it was struggling to find purpose. Okay, I hope guys you will like my video. आंटी आप बहुत अच्छा टाइम पे आए हो। मैंने कहा अच्छे टाइम पे आए हो आप। ठीक है, कटले कटले टमाटर, पतली पतली प्याज और लहसुन छील लेना। और याद रखना इसको थोड़ा सा छुरी से घरे कर लेना। ये दो तीन पत्ते मिर्ची और जीरा लहसुन डाल देना।
Okay, guys. So now I moved on topic of
orchestration, orchestration, orchestration,
कितनी सीटी हुई आंटी? अभी नहीं हुई होगी अम्मी। एक दो और ले लो। So here you can see I'm going to move on next topic. So बन गई आंटी रोटी बना दो आंटी दाल भी. So here you can see we are going to move on next workflow, that is the orchestra. Okay, so here you can see orchestra workers workflow in line graph. Okay, in this orchestra workers pattern, a central LLM, the orchestra dynamically break down a task into a smaller subtask. Okay, it will dynamically break down smaller task into a smaller subtask. Each subtask is sent to a worker LLM, and finally हो गए आंटी. आज भी गए थे बाहर है? आज नहीं है, आज तो घर पे ही है।